The goal of this video is to help you calculate the area of a circle. The most classic and simple formula for calculating the area of a circle is simply pi r squared. So we are actually in the free website VCalc here that has the formulas pre-programmed for you in the area of a circle calculator. So if you come up to this first one, you can click on area is equal to pi r squared. And in this case, you can enter in the radius, that's the r, from the center to the edge. So in this case, I'm going to go ahead and say that is 4, and it handles units. We're going to leave them for this whole demonstration in the default units, which are meters and meters squared. But you can change those to English units like inches or even miles, nautical miles, clear out to very large astronomical units. So in this case, it basically does the formula of pi times 4 squared and calculates that the area of that triangle, in this case, is 50.265, etc., meters squared. Now, if you don't know the radius, but you know the diameter, which is simply 2 times the radius, but sometimes it's easier to measure, you can use this following formula. It's a slight variation on that one. Again, enter the diameter. We'll put it in as 7. And it will calculate the area of this triangle, or it's not triangle, circle rather. Then the last one that still gives you the formula for an entire circle is again a variation on the exact same formula, except in this case it will let you enter in the circumference. That's the length measurement for the entire perimeter. So if you can measure that off in a circle, this formula, the third one down, will compute the area of that. And this could be useful in some areas, like in farming where you have a circular paddock. You may not be able to calculate, maybe there's something inside you don't want to disturb and you want to know the area inside it. So you basically walk off the perimeter, the circumference, and you say the circumference in this case will make it a bigger number. Say it's 56 meters, and it will tell you that inside that area is almost 449.55, etc. meters squared. So again, based upon the circumference. Now we're going to move to sections of a circle, the area of sections of a circle. So what we're going to do is we're going to start with what they call a sector, or like a wedge, the piece of a pie, if you will. So the area of a sector is defined by, first off, the size of the circle, which is defined by the radius, and then the angle that is swept out to create the wedge, to create the piece of the pie, if you will. So in this case, you need that r and that theta. So we're going to go ahead, and I will change the units in this case because I tend to work in degrees more. But we'll basically say our radius of our circle is 5 meters, and the angle we'll straight up say is 45 degrees, approximately what they show here. In this case, it will tell us that the area, in this case in the gray, is 9.81, etc. meters squared. Again, you can change the units, inputs and outputs. Okay, so that is the area of a sector. So now we're going to go to what is called a segment, an arc segment. If you think of a section of the circle being an arc, if you take the radius to define the circle and then sweep an angle and then connect the 2 points, it basically creates this arc segment in blue here. And there's 2 ways to define it. One is, again, with the radius and the angle, but the other could be the radius and then the measurement, the maximum measurement coming into the circle. In this diagram, it is this h. Maybe a little hard to see, but it's basically the measure from the edge of the circle down to this chord going across from the 2 points in the radius. It's the same circle, you'll notice, but 2 different ways of measuring it. And there are 2 different formulas. So the segment area, which is a function of radius and theta, if you click on here, that's the formula, where again you put in the radius and then the angle. Put 34 degrees in this case, and again it'll tell you the area in this case of the blue area. And similarly, instead of the theta, you could put in the distance from the edge. So again, we'll say 5, and we'll say our distance is 1 meter from the edge, and it'll tell us again that area. So again, simple formulas, but again, you don't have to sit there and program this into your calculator. It's already here for you in this free calculator in VCalc. Okay, there's 3 more cases we're going to give you. They are a circle that perfectly fits within a triangle. If you know the sides A, B, and C, this calculator will tell you, it computes first the radius of the circle that is inside a triangle, and then it will calculate the area. So that's this formula. So it's the area of a circle within a triangle. So if you give the lengths of the sides, it will calculate that area. And then similarly for a circle that is on the outside of a triangle, so again, give it sides A, B, and C, and it'll tell you how big of a circle would go outside. Circumscribe it, so click on this right here, and it'll do the same for me. So we'll go ahead and do this one. We'll say it's 4 meters, the triangle 5 and 6, and it will go off and calculate that circle that is around the outside of that triangle that would have an area of 28.7213. All right, and then last but not least, we're going to tell you about the area of an annulus. An annulus is the difference between two circles. So if you have one circle defined by the larger radius r, which is the blue, and then the lesser circle, which is defined by the small radius here, then the difference between them in blue here is that area can be calculated as the difference, and that is the area of an annulus. So in this case, we'll go ahead and we'll say the outer radius is 8, and the inner radius we'll put down as 6, and therefore that area in blue is 87.96, etc. Meters squared. So again, very useful formulas in VCalc, free calculators available to anyone who needs them at vcalc.com.